Evening, everyone. Let's get started. Today's topic. We are discussing statistics, right? So, in the previous class, we discussed in statistics about the mean, median, mode, and then range. There is no direct formula or function for range. So, we need to find max and min. Then we want to go for the range. And then we also discussed about the frequency, right? So, for that, we refer the histogram. So in continuation to that, today in statistics, we are going to discuss about a new concept or the topic called as a linear regression. So where it is used, we are going to talk about that. And today we are here. And then this Wednesday, our class is like project planning and design. We will directly get into the project phase. And then next week, we'll talk about more on final project collaboration. So you will showcase your project to the peers, to our class, and then based on the input, you will fine tune that. And then the final class will be the project presentation. That is on April 30th. And then we'll get into the next software for data analytics and visualization, that is Tableau. We will talk some theory about the linear regression, what is correlation, how it scatter plot is going to help for that to analyze the linear regression. Once we discuss the theoretical part, as usual, we will take this workbook and we'll do some practice, all right? And then I have one worksheet included for you to practice the Power Query also, okay? So you can practice that as well. And today, as we are going to start next class, as we are going to talk about the project planning, today I will show you some few sample data questions that our previous data analytics students used as a questions, okay? What questions they asked and where they get the data. Maybe I can show you some few questions, okay? You can get some idea about that. So that is going to be today's agenda. All right. So what is a linear regression? All right. Let's say I have y-axis here, okay? And then I have x-axis over here. On similar line, let's say I have y-axis and then x-axis. Relation. Is there any relation? Is there any relation between these two variables? For example, let's say that we have outside temperature, okay? Let's say that we have sun, okay? This is my sun, okay? We have sun, and we are measuring that in terms of degree Fahrenheit, okay? Degree Fahrenheit. And let's say that the outside temperature is somewhere around like 60, and then it goes like 65, 70, 75, 80, 85, 90, okay? The max, let's say that we are measuring up to 90. And then here we are measuring the sale of the, let's say, ice cream, okay? The sale of the ice cream. Let's say here the sale is like 100, and then 200, 3, 4, 5, 6, 7, all the way it goes like that, okay? $700, like that. If outside temperature is 60, okay, freezing cold. So what will be my sale? Let's say that only $100 I have sold, okay? And then 65, okay, 200. And it's very hot outside, 90. So what will happen in this case? More ice cream sale, right? More ice cream sale. So we have like these data points now. We have like this. We collected various data points for a week or a month. We have plotted like this. These are all each data points. On a particular temperature, how much quantity of ice cream was sold. On a particular temperature, how much was sold. So this is the data points. you can see all the data points are scattered like this, right? So we call this as scatter plot or scatter slot chart. Okay, scatter, SEA. This is the new chart that we want to discuss towards scatter chart, CHA or T. This scatter chart is always used to compare two things in relation. Okay, so this word is very important, relation. So we call this technically, statistically as, is there any correlation between these two? Any correlation exists between this? We call this correlation, CORREL, correlation. We call this sort of analysis as correlation analysis. When we have dot points like this, we always try to draw a straight line that exactly fits to these data points. I can even draw like this, but the idea is not that. I want to draw a line like this that exactly fit to this model, fit to these data points. Yeah, a line, L-I-N-E, line. So we call that as a linear line. Yeah, this line is also called as line of best fit. I'll be using a lot of terms. Just try to understand those terms, okay? I'll be repeating those terms over and over again. You will get that. This is called line of best fit, okay? Line of best fit. How well the points fit to this line? How close is those points to this line? If all my data points are exactly on top of this line, which means I have a perfect fit. Okay. You can see whenever the temperature increases, my sale of ice cream increases. So is there a relationship between these two? There is a direct relationship, right? When temperature increases, my ice cream business goes up. So there is a direct relationship. Here we need to understand two terms. Whatever the data or the thing that variable that I plot in x-axis is called independent variable. Okay, so this is independent. This don't depend on anything. Okay, independent. This word is very important here. Independent, P-E-N-D-E-N-T, independent. It don't depend on anything. Whereas this ice cream, right? The sale of the ice cream is depend on the temperature. You got my point? The sale of the ice cream depends on the temperature. Temperature increase, my ice cream sale increase. Temperature decrease, no one is going to come to my shop. Right? This always depend on this. So we call this one as dependent variable. Dependent. This depends on this. This depend on this. Okay. So independent, dependent. So always we place the dependent in y-axis. Independent will place in the x-axis. So we have to name something for this line, right? It goes like this. We call this as positive correlation. Yeah. So whenever I extend this line, let's say that it goes like this 90, 100, 110, it goes like this. My sale also goes. Always it moves toward the positive direction. Okay. All these are positive, 100, 200, 300, all are plus. Here all are plus. So we call this a positive correlation. Okay. So let's recollect. Linear regression is always comparing between two variables. Okay. We take two variables and we compare whether this is dependent on that. So that's what we are going to compare. Always we place the independent on the x-axis. The dependent variable we place on the y-axis, and then we get the data points and then we plot. And then we try to draw a line that best fits these data points. And then if it goes towards the upward side like this, then we call that as a positive correlation. All right, let's try to understand with another example. Okay, let's take, here we have a sun. same sun, okay? Same sun, and then same temperature, outside temperature 60, and then all the way it goes to 90. And let's say this time, let's say we started this as 100, right? 100, 200, 3, 4, 5, 6, 7, 8, 700, like that, I'll place, okay? 700, I have 700. So this time I want to compare the temperature, degree Fahrenheit, okay? Temperature with the sale of the coffee, okay? What is the sale of the coffee shop now? Okay, let's say that I'm opening a coffee business. How is the sale for me now? The temperature is 60 now. Okay, very cold, freezing cold. Everyone is coming to this shop and they want to take coffee. Yeah, it's very cold outside. Say they want to drink something hot. Yeah, so they want to drink something hot. So they come here. So 700 quantities sold. And then gradually temperature increases, okay? And then 90-degree outside, very hot, right? So very sweat. So no one is going to take coffee that time. So maybe 100 people, let's say, here. So what's happening here? When the temperature increases, this one is going like this. You got it? So this goes, if I plot the data points, it will be like this. In this case, if I try to draw a line of best fit, you can see the line points towards this side. When I extend this one, what will happen? Let's say that it goes like this, okay? So here, this is y-axis, right? So this is y. So this is y. One second, let me hide that. So this is y. And then this negative y. See, 100 minus 100 minus 200. That is how we plot the graph, right? So if we extend this linear line, this line, it goes towards the negative direction. So we call it as negative correlation. So it depends on the situation. Either it can go to positive side or it can go to negative side. So what we try to understand here, is there any relationship between these two? What is the right time for me to open this shop and what is the right time to open this shop, right? So that is the idea. So we compare the relationship between the two data and come to a conclusion. So we call that as correlation analysis. For that, we collect the data points. So what is the sale of my ice cream? When the temperature is 60, I get the data and plot that in the Excel sheet. Like that, I measure all the information for the past 1 month or so. Then finally, I will plot this and I will analyze and say, yes, this is the analysis. When the temperature increases, definitely the sale of the ice cream goes up. When the temperature decreases, here the sale of the coffee shop goes high. If the temperature increases, it's very hot, only few people consume the coffee in my shop. So this is a classical example which everyone used to give when it comes to a scatter plot. So the plot that is useful for this sort of analysis we call it as scatter plot. And this is in Excel and we can use this. The line that we draw here is called as a line of best fit. And this is also called as trend line, okay? Trend, T-R-E-N. What is the trend? What is the pattern, right? So trend line. In Excel, if we just plot all these dots, and then if you turn on the trend line, it will automatically find the best line to fit the data points and will provide us the line for us. And then again here, what the variable that we place on the x-axis, we call that as independent. And this sale of the coffee always depends on the sun. So we call as this is dependent. This is depends. This depends on the sun, right? So we call this as dependent variable. This is independent. All right. Let's go with another example. Okay, so this is one set of example. Let's go with another example. Let's say I have two cases here. Okay, number of hours studied and then the test score. Okay, let's say a student studied for 1 hour, student studied for 2 hours, 3 hour study, 4 hour study, 5, 6, 7, 8. Okay, 8 hours. A student studied for 1 hour. Okay, he got, let's say, 55 mark in his exam. All right, 55, 60, 65, 70, 75, 80, 85, 90, 100. Right? Let's say a student studied for 8 hours, which means obviously his score is going to be somewhere here, 100. Yeah, he studied for 8 hours. Let's say this person studied for 2 hours. Obviously, maybe let put for this person. Let's say this person studied for 2 hours, maybe here, this person here, 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 like this it goes, right? So if we try to plot all this here, more hours if we spend in studying, we get more marks, right? So the test score, okay, whatever the test score that you are getting always depends on the number of hours you are studying. So this is one analysis at universities. How many hours you prepared for this exam? They will tell that how many hours you prepared. They enter everything. And then on the analysis, they'll find that, oh, it's positive correlation, CORRLEAT, because it goes towards the positive sides. Okay, positive correlation. So what are the terms that we need to remember here? Linear. This line is called line of best fit. Okay, line of best fit. These are the data points. Line of best fit, or we can say that's a trend line. And this always we keep the hours of study. Okay, hours of study. How many hours the students study? This is independent. This is independent variable. This always depends your marks. Okay, the student marks always depends on the number of hours they spent in studying. Yeah, less hour, less score. More hour they study, more mark. All right, let's take one more scenario and then we stop this discussion. Okay, one more scenario. Let's say screen time, 1 hour, 2 hour, 3 hours. Let's say all the way it goes to 8 hours. Okay, 8 hours. Let's say 5, 5.5, 6, 6.5, 7, 7.5, let's say 8, 8.5. Okay. I spent only 1 hour on my screen time. I watched only 1 hour a TV show or something. I have a sound sleep. 8.5 hours I slept. Okay, my sleep time. SLEEP, sleep time. I have a nice sleep because I watched only 1 hour my screen time, watching mobile, watching TV, iPad, all those electronic gadgets. Okay, nice sleep. On the other hand, let's say that 8 hours I spent. So my sleeping gone. Only 5 hours I slept. Yeah, only 5 hours. And then 2 hours I watched screen time. So here, 8 hours only I slept. 3 hours I'm spending on screen time. Okay, my sleep time gone. Like this, gone, 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 gone. 8 hours I'm spending on the screen time. Only 5 hours I slept. Next day, very tired at my workplace, not able to perform well. I spent only 1 hour on screen time. I slept nicely for 8.5 hours. I performed well. Yeah. All right. So here it goes. Less the time spent on the screen, more the sleeping hours. Right? Here, less the hours spent on the time, poor score. More the hours you have to spend here, more test score. Okay. So this is a little complex. So what is this one called as? Negative correlation. This is called negative correlation because this goes towards the negative side, right? As I said, it goes towards negative side. These are a negative 4.5, negative 5.5. It goes like this. So we call this a negative correlation. Now, just by looking at the graph, you want to identify whether it has a correlation or it don't have a correlation, whether it has a positive correlation or it has a negative correlation. Okay, so that's what we want to identify. Let's say, because Excel is going to do all that pretty much job for us, we need to discuss, we need to talk about that. That is the only thing we want to discuss. Okay, how about this one? It's positive correlation or negative correlation? It moves towards the positive side.
Positive correlation.
Good job. So this moves towards this one. We call this as negative correlation. And let's say your data points is like this, spread all over like this. So in this case, we say no correlation. Okay. So this is no correlation. Somewhat our data point should be closer to the line of best fit or the trend line. Then we can say there is a correlation, and we say whether it is a positive, it moves towards this direction, or we say it's a negative correlation if it moves towards the negative aspect. If I can't do anything with this, then we call as no correlation. There is no correlation.
Sam, I have a question.
Yeah.
Is the trend line always going to be straight?
Oh, in case of linear, there are a lot of regression model in this class. Good question, Vinny. So here we'll be studying only about the linear regression. It's always going to be a straight line. If you study about the polynomial case, you might find lines like this, like a parabola and then hyperbola. There are a lot of name for that. Here we strictly focus on linear. Yeah, good question. Yeah, when you advance this in statistical, you will come across those things, multiple linear regression, those things you will get polynomial. Yeah, in that scenario, it won't always be straight. You will get like this and all. Okay. All right. So here it's strictly a line of best fit is a straight line, linear. All right. All right. So this is the definition that our senior instructor at PPL used. So I'm keeping the same thing here from Harvard Business Review. Okay. So this is the definition for regression analysis. So let's say, suppose you are a sales manager and you are trying to predict the next month number. So what would be the sale for me next month? Okay. You have the sale history for the past month, past year. So what would be my sale for the next month? You want to predict that. So regression analysis, the trend line is always is about the prediction of the future. It's about forecasting. So what will happen next month? So now you know there are a lot of factors that is going to affect this number. Okay, so what will be the next month's sale? Lot of factor is going to affect that. It could be a weather, like we discussed about the temperature, right? So if outside temperature changes, my sale of the ice cream is going to affect me. If the outside temperature, same with the coffee also, right? So it can be a competitor's promotion also. If our competitors spend more money on the promotion, so my business is going to impact. My business, the month's number profit is going to impact. Regression analysis is a mathematical way of sorting the variables does indeed have an impact. So there should be an impact with the two variables as we discussed, dependent variable and independent variable. So that is the two variables, dependent and independent. We always keep the independent on the x-axis and we put the dependent on the y-axis. Remember the picture, ice cream picture, the ice cream sale always depends. So put those things in y-axis, dependent on the x-axis, the sun. Okay. The test score always depends on number of hours a particular student is studying. All right. So what we do to analyze that, to find the relationship between two variables, first we need to plot the scatter plot like this. So we identify, we gather the data. All right. Let me pick something. we gather the data, and then we identify what should be my dependent variable and what should be my independent variable. So these are the terms important in this correlation analysis, okay? So what should be my dependent variable? Dependent variable always go here, okay? And then independent variable goes here. And then you plot the dependent variable with one independent variable, you get a scatter plot like this. So we call this as a scatter plot because all the data points are scattered here and there like this, right? So we call this as a scatter plot. Now, what is the idea? Is there a relation between these two variables? Is there any correlation? That is correlation. How to find that? Let's say the y-axis is the amount of sale, and then let's say the x-axis is the total rainfall. The total rainfall here act as a independent variable. Yeah. Before we talked about the sun. Now let's talk about the rain. Okay. The rain is outside. And then we have the product here. Okay. So what is the total sale here? Probably we notice that the sale are higher on days when it rains. Okay. When it rains a lot, we notice that we have a huge number of sales. When the rain is less, we have less sale here. Furthermore, we can analyze this very easily by drawing a line through the chart. The line that exactly goes to the center of all the data points. Yeah. We call that line as line of best fit or the trend line. So we call that as a regression line. Or you can say that's the line that best fit the data, the line of best fit. The red line is the best explanation of the relationship between these two variables, that is dependent variable and independent variable. Let's say in this case, we discussed about the rain, right? Let's say it's heavy rain and we sell the product like a rain jacket. Okay, we sell rain jacket and we sell umbrella. Okay, so if the rain is heavy, lot of people come to my shop and purchase rain jacket, right? My sale goes here. If there is no rain at all, no people will buy. So that is a perfect relationship between this product sell and the rain. Yeah. All right. So now we discuss that. Let me draw something here. Already I said, if we have the scatter plot like here, like that somewhere, we can't draw the line of best fit. We call that as no correlation, right? So there is no doubt in that. So now we'll give a various terms for the correlation. Okay. First, I will draw. This is positive correlation. No doubt in that. Positive correlation, negative correlation, and then negative correlation. Now, let's say all my data points are exactly lying on the same point, lying on the same line. We say this as strong correlation. Okay? Strong positive correlation. We have to use all these terms. Okay? So that is the only thing that we need to do here. Okay? When all the points lie on the same line, strong positive correlation. Let's say we have something like this. So this is weak. Okay, weak. It's a weak. It's positive only. It's positive correlation only. Okay, positive correlation. But this is weak because most of the data points are away from the line of best fit. So we say this is a weak positive correlation. Here we say strong because exactly it lies on that line. And then here we see it's not too far like that, but not touching, but somewhat closer to the line. So here we say moderate. Okay, moderate. Just remember these three words: strong, weak, moderate. When you see the plot like this, immediately you have to tell, oh, this is somewhat too much away from the line. I will say weak, positive, but it goes towards this side. So positive correlation, weak, positive correlation. This one somewhat close towards the line. Okay, moderate, positive, again positive we have to say. Okay, moderate, positive correlation. This one is exactly lying on the same point. So strong, positive correlation. There is one more case where we can't draw any line this way. We say that as no correlation at all. So here you would have guessed, right? So you name it. Let me plot the data points. Okay, how about this one? Everything lying on the same line. So strong, but going towards the negative direction, right? So negative correlation. But this is strong only. Strong, negative correlation. How about this one? Somewhat closer, right? So moderate, but negative correlation. All the data points is somewhat far away from the line, right? So this is weak. However, it's a negative only, but weak, negative correlation. Okay, you will get the picture like this one. So as we talk about only the linear correlation, we talk only about the straight line diagrams. Okay, strong, moderate, weak. You remember like this: strong, weak, in between moderate. Positive, negative. Correlation. What is correlation? The relation between two variables. All right. If you want, you can take a note. Let me leave this for now. Let's go to the next slide. All right. Let's try to identify some correlation and see how our understanding is, okay? Or else we'll again review the topic. How about this one, the first one? First, identify it's positive or negative. Step by step, we'll go. The first one, okay? Is it positive or negative? This one?
Positive.
Positive, yes, because it's moving toward the positive direction. Okay, positive correlation. How the data points here? Strong, yes, somewhat touching the line, right? So strong, that's right. Strong, positive correlation. Good job. How about this one?
Weak, positive correlation.
It's weak. The third one, this one.
It is negative.
Strong, negative.
Yes.
Negative, because the line goes this way, right? So it's negative. Good job, Vinicius and Ina. Negative, but all the points are touching, right? So we say strong and we also say negative. How about this one? It's negative, correct?
Yes.
Negative.
Negative.
Correction.
It's strong, moderate, or weak?
Weak. Weak.
Weak.
Weak. Good job. This is negative. Is this strong, weak, or moderate?
Moderate.
Like moderate, correct.
Moderate.
Yeah, only 2 points are touching the lines. Other points are away from that line, but not too far like this, right? So we say that as a moderate. How about this one? This one?
No correlation.
No correlation.
No correlation. Perfect. Perfect. One more time, okay? How about this one?
No correlation.
No
correlation.
No correlation. Just follow my mouse. This one.
A strong positive.
Strong positive.
Good job. First, you identify whether it is positive or negative, then include strong, moderate, or weak. Yes, strong positive correlation. Now follow my mouse.
Mhm.
Strong negative.
Strong negative.
Excellent. Strong negative correlation. How about this one?
A strong
No,
Weak.
moderate.
No.
Moderate.
Moderate positive.
Moderate positive.
Yes, everyone got the concept. Positive. How about this one now? Same, moderate, but it's
Negative.
negative.
Moderate.
Okay, this one,
Mhm.
Positive.
Weak.
positive, weak. Correct. Positive, weak,
Weak.
correlation. This is
Mhm.
positive, weak,
Negative.
negative,
Weak.
correlation.
Negative. Weak.
Negative.
Yeah, first time we are listening all these terms, it will be a little bit a thing, but you will get that, okay? You will get that. First, identify the line, whether it is positive or negative. Then look at the data points, how it is spread. Then we can get that. All right. So now, just looking at the data points, we are saying that it's a strong, moderate, or weak, right? Instead of that, if we have a number, right? If we have some numerical number, it will be very easy to identify that, right? So for that, we have a mathematical calculation that is called as R squared. Excel will give that R squared value for us, okay? So there is a lot of mathematical formula behind that. We are not looking those things, but once we draw the trend line, we can attach this R squared value to the trend line. Based on the number that it is giving, then we can identify whether there is a relation or a strong, moderate, or weak, okay? So R squared value, this R squared value is a single number that expresses, that gives us how strength the correlation is, okay? The minimum value is 0. The maximum value is 1. If it is 0 means there is no correlation at all. If R square is 0 means, if Excel gives you the R square value as 0, then you can see all the data scatter plots are here and there. We can't draw the line. It's no correlation. If all the data points exactly lies on the same line, then it will be R square will be 1. We call that a strong correlation. If you see that R square value is 0.8, if you get 7, okay, 7 or 9, then you can say it's moderate. If the R square value is 0.3, which means if you get 0.2 or 0.1 or 4, 5 something, you can definitely say it's a weak, okay? So now don't worry about this scattering, how I can just go for this number. Looking at this number, you can say this, okay? Maybe you can note this number. We'll work with the Excel sheet, and then just by plotting and then having that R square value, you can immediately tell whether it is strong, moderate, or weak, okay? All right, 0, no correlation, 1, strong, 0.8, moderate, and 0.3 is weak. All right, so now let's talk about this one. Correlation is not causation. What is causation? Okay, so let's go with an example. Always we'll try to understand something through example, okay? Let's say that I'm plotting things like that. Now I am taking this ice cream in the x-axis, the sale of ice cream, okay? The kids, it's summer, the kids are coming to my shop and eating lot of ice cream, okay? And then they're going to the swimming pool, okay? They're going to the swimming pool, and then a lot of kids, they're swimming. So in the hospital, they are recording most of the kids got drowned, okay? DROWNED, drowned. Most of they're seeing lot of records like this. When I plot graph like that, it's giving me like a positive correlation. Do you think that eating lot of ice cream make them to drown while they swim? But we have proved that, right? So we have proved that, and the plot is perfectly showing here, okay? Whenever we have the data like this and it proves something like this, we have to think whether is there any sense behind the data, okay? Is there any logic behind that? Logic. Is this make any practical sense, okay? Practical, Practical. Is that make any practical sense? Eating the ice cream, will everyone get drowned when swimming?
No.
No. So that is what, definitely this doesn't
At
cause...
least that the ice cream have a lot of liquor.
See here, this doesn't cause this. So that is causation. So what they say, even though you have a data points like this, you can't, we have to be very careful in our analysis that definitely this is not the cause for the people who getting drowned. There should be some other third factor here. Okay, we forget the third factor. The third factor is the sun. Okay, the sun is the cause for both the thing. Okay, as it is summer, okay, as it is summer season, ice cream sale is more. As there is summer, more people go to swim, right? So the third factor is this one. So this two is not related, even though it exactly shows this. Let's go with another example, then we can understand better. Same only. Let me erase everything. Okay. Let's say here what I can, let's say same thing, ice cream, okay? Ice cream in the beach, ocean, beach, whatever. And then here, let's say that shark attack, okay? People are surfing, this is shark, let's say shark, okay? There is more shark attack. More shark attack. People eat lot of ice cream and then they go for surfing in the ocean, okay? Surfing, and they got attacked by shark. So eating ice cream, do you think eating ice cream causes the shark attack?
No.
No, definitely there is a third factor, that is the sun. As it is a summer season, people are going to the beach and they have the ice cream and they're going to surf. So they get attacked by shark. And definitely there is no any relation between these two. This doesn't cause this, right? So that is correlation is not causation. Famous sayings, okay? So statisticians use this one. So we have to be we can easily prove this point also, right? This will also give us a perfect positive correlation if we try to plot this one. But we have to remember what is the third factor. What is the third factor behind the scene? So that we need to brought into the picture. Okay, as it is a summer season, everyone goes to the beach, they buy ice cream, they go for surfing. But definitely this is not the cause for this shark attack. So correlation, this relation, what we see here is not the cause. You got it? Yeah, this is one important thing, that when you talk about scatter plot or linear regression model, you will be asked about this question. Okay, give some example. Just give these two examples. Okay, ice cream versus students getting swimmers getting drowned in the pool. Okay, ice cream versus shark attacks in the ocean. Right? What is the third factor involved in these two? Sun. Okay, the weather, the climate. All right, so there is a two beautiful video that is going to explain this. I'm not going to play that now because I think this is some lengthy video. When I share this PDF file, right, please take a moment to watch these two videos. Okay, this is not equal to that. And what is the danger of mixing up causality in correlation? Okay, so nice to, this is a TED show talk. Okay, just please watch these two. And you want to remember this, correlation is not causation. All right. Whenever you work with regression analysis or any other analysis that tries to explain the impact of one factor over another, remember the saying, okay, that correlation is not causation. Here is why. Just because two things happen together, okay, just because sale of the ice cream and the shark attack is happening together, it doesn't mean one caused the other. For example, ice cream sale and shark attacks may both increase in summer, but eating ice cream does not cause a shark attack. Both are related to hot weather. This is a classic third variable scenario. The correlation between Shark Tank and ice cream sale exists, but one doesn't cause for another. Both are affected by season. As it is summer, all people are going to beach. I hope you understand this, right? Causation? Yes. Think that, is this make a practical sense? Okay, so that is what we want to do. All right, so let's open the regression analysis workbook, and then I have a two worksheet to practice. There we drop the trend line and we'll bring the R square value, and you will be naming that. Okay, let's do that. Before opening that, let's finish this theoretical part also. Power query. I think Power Query we already discussed. Let's review that one. If you remember, the pivot table or the Tableau or Power BI works more effectively with tall data. You remember we discussed that, rather than wide data. In order to bring that, what we want to do, we want to convert that. So it's a quick process in doing in Power Query. We need this data. We need this data. We don't need this data, right? This is good for human readable format. When we want to send this data to a pivot table or Tableau or Power BI, we need to convert this into this format. I have one practice sheet. So if you practice that, you will get that idea. Let's say that we have state names here, and then they recorded sale or profit, whatever, from Jan to December, and we have the numbers here, right? So this is very good for us to read. So what is the profit in Florida during June? We can go and easily capture that, right? Whereas our pivot table or the Power BI or Tableau don't want this format. We need to format as a tall file or a long file format. Sometimes this is called as pivot data. Sometimes this pivot data can also be referred as cross tab. Okay, if someone is using this term, you think that they are talking about this kind of data format. Okay, they say cross tab also. Cross tab means this kind of data structure or pivot data. This pivot data we want to unpivot. This cross tab we want to unpivot. So we want to bring like this. Okay, we want state, and we want all the month in one column, and all the values that we are seeing here as one column called profit or sale or amount. See here, all these go in one column here next to state, and all these values go in another column. Just we need only 3 columns to data analysis. I have the worksheet for that as well. We'll do one thing. We'll take a break. Once we come back, we will complete both the worksheet. Okay. Oh, all right. So I'll do one thing. I will turn on the timer and we'll come back. Let's pause the recording. All right. Let's try to understand what we discussed theoretically. All right. Here in this workbook, I have 2 sheets. One, let me maximize this a little bit. All right. So here we have the data. We have like 8 or let's say 9 observations. Okay. All these are beaches. Okay. Beach of British Ocean beaches. What they're trying to understand here is the granules of the sand, okay? How small the sand granular level, okay? If that has any impact on the slope of the beach, okay? On the slope of the beach. So that's what they're trying to understand. So they literally, the team, they, let's say that they went and then measured each size of the sand in terms of millimeters, that is the diameter, and they plotted here, okay? They captured the data. For this beach, it's like 0.17 millimeter. And then they measured the slope of the beach in degrees, that is 0.63. So like that, they went to all the beaches in this British Ocean, and then they have this data. So using this data, now we want to understand, is there any relationship between these two? More the size of the sand, more the slope, like that. So that's what they want to find it out. For that, we are going to use the scatter plot. And then we want to add the trend line, the trend line in the sense, the line of best fit, that we want to try to do that. And we see how strong is the correlation by adding the R squared value. You remember I said about the number, that R squared number. If it is 0, no correlation. 1, it has a correlation, right? That's what we try to understand here. Select the cell ranges from B3 to C12. We select B3 colon C12. And then we want to add the scatter plot. We go to insert. And then we go to chart group. We don't need to go for recommended chart as we always do, because we know here what we want to plot, right? We want to plot the scatter plot. So we directly go to the chart group and click this down arrow and choose scatter plot. We have this here. See here, all the data points are captured here. We have the data points in the scatter plot. Let's go to the chart elements. And then this time we will add the axis title. Okay, always we used to remove this, right? So this time we need that. We need the axis title. So let's turn that on. And then in the horizontal axis, we always keep independent, right? What is the independent here? The granules, granules of sand. That is measured in millimeter. I will just make mm, okay? Enter. Maybe I can make that bold. And then what is in the y-axis? Y-axis is dependent. This depends on the size of the granulars of the sand. Let's go here and then we type here beach slope. In bracket, I will type in degrees, okay? In degrees. And then maybe I can make it this bold. All right. We selected the cell and we added the scatter plot. Now the next point is we need to add the trend line, right? We need to add the line that best fits the data here. To do that, we select the chart. We go to this plus. And then here we add the trend line. Turn that on. We have the trend line here. So now looking at the data, we want to say if it is strong or moderate or weak, correct? To do that, if we have that number, that will be helpful, right? So that is R square value. To add that R square value, we can simply double click this dotted line, the line of best fit that we added. Just double click that. And then here we can go, let's go down. And then we want to add the R squared value on the chart. We turn that on and then close this box. We have this value. Let me go to home and then make it bold. And then now looking at the R square value 0.9, please tell me what we can conclude from this. It is positive, correct? It's positive, moving toward this direction. It is strong, weak, or moderate. 0.9 is
Is
just
only one is
Yeah.
a strong, this is a moderate.
Almost one.
Yeah, R square is
So it's-
almost 1. Yeah, we can say strong,
Strong.
moderate. Yeah, moderate to strong. We can say like that. Yes, that's right. Moderate, strong. But this is not weak. So what we can say from this here is, this explains very well that the slope of the beach depends, is always related to the granules of the sand, the diameter of the sand, correct? More the diameter, the more the slope of the beach is. So that what they finally want to prove, right? So they want to prove that. So they went for each beach and then measured, and then they plotted this and they proved that, yes, this is true, like that. Let's go with one more example. Let me right click and then price elasticity. Here we have olive oil price and then the quantity. So we want to compare this. We want to see how it is related, both are related. So let's do that. We want to select the cell from B3 to C24. Let's do that. And we want to add the scatter plot. So we go to insert and then the chart group. We click the scatter plot and then we select that. We will just move here. And we add the axis. And we say this as price. Enter. And this one is quantity purchased, right? Quantity purchased. We'll try to add the trend line here. By clicking the plus, we add the trend line. So what is this one?
Negative.
Negative correlation, correct.
Correlation.
So do you guess is it moderate or strong or weak?
Weak.
Maybe
You-
weak.
Maybe weak.
Maybe weak. Okay, let's,
Between moderate or weak.
all right. So let's double click this dotted line, and then we go and then display the R squared value. And then it's 0.7.
Moderate.
Yeah,
Point-
moderate. We can do one thing. Maybe we can try with some other chart. Yeah, we'll see how this looks. Yeah, this looks good. Yeah, practice these two sheets. That should be fine. In your project, when you choose the project, try if you can do some analysis related to frequency distribution, right? Using histogram or analysis or finding relationship between the two variables like this using scatter plot. So that should be good, right? So rather than going with the regular chart like column, bar, and pie, maybe you can try scatter plot and histogram this time. Okay. Yeah. So just frame the question. We need to frame the question, and based on the question, we can think whether for this question we can go with histogram or the scatter plot. All right. Yeah. I expect this kind of project this time. If you I know this is the first time we are discussing in the class, not in L1, 2, and 3. If you really need help, you can always contact me. Okay. I can work with you and looking at your data. It doesn't mean you have to do all the work by yourself. You can ask. Yeah, you can ask how to proceed further. I have this data. I want to do something using these scatter plots, and but will this data work for me? You can always check with me, okay? Yeah, if you include these things in this project, then definitely you're good as a data analyst, okay? These are some analysis things. All right, so let me save this. I will put this in the Google Classroom. Please download this, okay? Download this and just try to work on the scatter plot. Okay, let me explain. Let's explain this. So what's happening on here? What's going on here? Can someone talk about this? We have a quantity here of the olive oil, and then here we have the price. What we can talk about this one? So the price is like $2, $4, $6, like that. It goes here, and the quantity goes like this. So what you can conclude from this one? How you can read this chart? See, plotting the chart is one thing, and interpreting the chart is a skill. Yeah. Can someone interpret this chart and discuss?
Right.
Yeah. Go ahead, Benicio.
Okay, so you are going to sell more olive while it is cheaper.
Yes.
Yeah, I think that's it. So it is and it's, as you can see, that the trend line is a moderate, so it is pretty common that based on the price is the quantity of olive they were going to sell.
Excellent. Excellent. Yes. As the price, okay, as the price increases, people purchase only less quantity. See here? If I say, hey, the olive oil is $12, then only 20, let's say these are all people, okay? Only 20 people is buying that. What I'm going to do, I'm going to reduce the price of the oil. Okay, $2. Oh my God, 80 people are coming to my shop, right? As it is cheap, more people buy. If it is costly, less people buy. We have a direct relationship. This is what is called as elasticity, price elasticity. In economics, macroeconomics, you'll be dealing all these concepts, right? All right, so let's put this in short. Did we discuss like this one, sandy beach? Yeah, we discussed, right? So more the diameter of the sand, granular sands, then the slope is higher.
Higher.
Yeah. So we have one positive and one negative example. Both are practical example, okay? All right, so let's close this one. And then we have one more thing to discuss. This power query is very simple. You can try that. All that I want to know is just explore to open the power query window, okay? All right, see here, we have the data like this. We have the state, and we have all the month over here, and the respective sales or profit for each state we have here. So this, as I said, this sometimes we call this as a cross tab also, or pivot data. Okay, cross tab is nothing but human readable format. Okay, that is what is called as cross tab. Most you will come across this term in Tableau. Mostly we will use this term cross tab like that. So this has been converted to unpivoted. See here, just with 3 columns, long, and this is wide. Before we do this, let me explain. If we feed this data in any analysis software, pivot table, if it is Excel, pivot table, or Power BI or Tableau, let's see what's happening. Let's go here as usual, insert, and then let's go to pivot table and click OK. See what's happening here. I get all the column name as individual fields, correct? I get state, Jan, Feb. What sort of analysis I can do here? Of course, I can bring Jan over here. This is the total month of sale in Jan. I don't know then what I want to do. I can go here. Only for the Jan, I'm doing the analysis. During January, I have sale this much in this state, this much in this state. Okay. For February, what I want to do? Okay, I want to bring it here. So it is too much of a complication involved in this. Okay. Where in this wide data. So let's see what is the advantage in pivoted data. Let's pick the same thing here. We go to insert and then pivot table. We go here. I have the total value. Let's place this here. See here, I got all the value for all the month. So this is actually the month here. So let's break it here. Jan, I got this. February, I got this sale. You see how the flexibility of handling the data in the analysis part, right? Now let's do this. Okay, so I'm going to move this here, or maybe here. That's totally fine. Cross tab. First step, select any cell within the data range, and then we go to data, and then from table or range. This I'm showing in a 365 version. In 2016, it will be a little different. Okay, when you practice, I think a lady using 2016. If you have any issue in this, let me know, lady. I will help on that. Okay, in 2016, it's a little different step. For now, we have to click this one, table or range, and then it opens the power. No, it will ask you. First, we need to convert this as a table, right? So it's asking you, hey, your table has headers. Yes, now this table has headers. So we say okay to that. And what it will do, it will grab all the data and take that to the Power Query. And then in this Power Query, you can see in the right-hand side, we will see whatever the operation that we are performing here, it will apply all the steps here. And here it's taking the table name as table 1. We can rename that. Okay, we can rename this sales data or whatever we can give. The idea is to bring all this header as one single header called as month, and keeping all these values as one single column called as amount or sale or profit, like that. So this data is perfect for us. So we want to, listen the term, unpivot all these things. We want to unpivot all of this. So what I do, the perfect data is here that I want. I want to right click that. And then here I want to say, keep this column, but unpivot other columns. Everyone with me? Unpivot other columns. The moment you say that, you get 3 columns. So now this is not attribute. You double click, and then what is the name of this one? Month, right? Month. And this one is value. Maybe we can say sales amount or profit. For now, I'll say amount, okay? It could be anything. Amount. All right, so now we have everything here. The next thing is to close and load. If I simply click close and load, what will happen? Just see here, I said that all the steps will be applied here. See here, unpivoted is here, and a rename column is here. So all the steps will be applied here. I can go here. Now, this is all what we want to do. If I simply click this close and load, it will go to my Excel sheet, Excel workbook, and it will open a new sheet and it will add it there. I have 2 options here, close and load, and another option is close and load to. I can select close and load to, and then it will ask me where you want to import the data in this workbook. You want, by default, it's going to new worksheet. I can say, just put in the sheet itself. Just to, I'm putting in the sheet itself to make a comparison, okay? I'm saying just place in this worksheet. I'm going to choose this location here, this location. And then I want to say, okay. See here? You can see this data now. So now this is ready for analysis. When you grab some data in the internet for your project, and if it has like this, you remember one thing we did last week. I think Rhode Island the school district project, right? Yeah. So that has a sort of all the student data with the various category, male, female, like that. And then we handle that in Power Query. So like that, if you have any data in a cross tab format or a pivot format, you can take that in Power Query and you can make like this, so that if you give this in the pivot table, it will be easy for us to further analyze the data. All right. So when I send this to you, you will see only the workbook. Okay. You can just practice this and let me know how this goes for you. The same step will work perfectly for 365, but in 2016, you just try or I'll send email. Okay. Yeah. Let's go back to our PowerPoint. That's Power Query. Okay. So as I said, some sample data questions that our previous data analyst participant they use, right? So you can click and open. Once I share this as a PDF file, you can click this link. Okay. You can click this and that will take you to this page. And here you can see, so we have two sheets here. Okay. Sample data question 1 and then sample data question 2. Let's see here. So general topic or the project area. So they typed here. And then what is the question? So this is what I'm talking about. Okay. Project question. And then what is the source? So where they are going to get data to answer this question. Okay. It necessarily don't have to be a question type. It can be like your research question also. Okay. I'll show you those things. Let's take the first one, household size in New England. So the question that this person want to find is which household size is more frequent. For that, this person is going to refer census data. All right. And then how does staff efficiency equate to salary? For that, this person is referring the Kaggle website, baseball player. And then Girl Scout. Oh, this I remember. This is like David's project, David level 1 project using the own personal data. This person daughter, she is in Girl Scout, okay, selling cookies and other things like that, and she asked permission from them and she get the data. How can we increase the Girl Scout membership in Providence this year, and what areas of city do we need more involvement? She did this project and then she handed over to that a Girl Scout team lead. Okay, so they're happy with her findings. Yeah, so this makes some practical. You did the project and you give some impact to the society. Data for good project. So these things we call as a data for good. Okay, doing some prospect for the community, helping them. Yeah. So, but you need to get the permission first, right? You need to get the permission. Is it okay to do that? Maybe we can hide the personal data and then we can use that like that. So I remember this one. And then local market sales trend. Does the sale of bread and milk increases based on storms? Do you remember what this one is? See the question? Does the sale of bread and milk increase based on storms? What is the storm here? The scatter plot. We can go with this with the scatter plot, right? Sale of bread and milk. We can put that in the dependent. These two is depend on the storm. If there is more storm, people buy more bread and milk. That's what the analysis is, right? So, and then I think she's yet to find the data that time, but later she got the data, right? So you have a question, then you can search for the data. That is also an approach, right? Two approach. You look the data and then looking at this data, what you want to find, what you want to get the insight out of that data set. That is one approach. Or you have some question in your mind and then look data for that. Yeah, gathering the data, collecting the data. And then this one, workplace injuries. Evaluate by occupational category and sure of, see here, not sure of question. So we love this. So if you type like this and show us, we will call you, will help you further to do further approach. See, not sure of question. This person is telling, I want to do something related to workplace injuries. and I know where to get the data from OSHA website, okay, Occupational Safety and Health Administration, right? So from this website, I want to get the data, but not sure of the question. And then options for young adult in Rhode Island who do not want to obtain a college degree. I think this is DLT data set. See here, DLT data set. What is the question here? How many job openings will be there? Those with and without the degree. Yeah, with degree and without degree. How many job openings will be there? So DLT website. Life expectancy around the world. Looking at trends in health and aging. If you remember this Gapminder, Ross Hosling, you remember he demonstrated by keeping the life expectancy versus the family size, right? So same thing. This is the same website, Gapminder. He is the founder of this Gapminder. This person went to that website and he was looking for the trend in health and aging. Not life expectancy, health and aging. And then languages spoken in United States home. Census data. See here, in census data, what are all the sort of things we can do? See here, census data, again, census data here. Comparison of English spoken in home in comparison to other languages. Do you think this is a question? This is a sort of research title, right? You got that? Your project work need not necessarily have to be a question. It could be a research also. Billboard charts. Frequency of artists in number on slots, multiple years, how long in this position. So for that, this person is going to refer data.world. And then elderly household needs, living independently versus assisted. For this, housingworks.rhodeisland.org website. These are all beautiful projects, right? And then, so we have one more list also here, a sample data question. We have one. Heart disease, health data.gov website by us. Yeah, you can refer all these. Yeah, so just take a look of these two so that you can get some idea about what you can do, right? All right, so once I share this as a PDF file, you can click this and you can, yeah, watch it. All right, so this is what we did today. So before we meet for our next class, okay, that is this Wednesday only, okay, for project planning and design phase, practice these two. And then as we discussed the mini project already, go to this website, data.providence.gov, and then we want this data, okay, Providence Police Case Log. You see whatever you can do with this data. If you're able to pose at least one question, move, put a check mark. You did that cycle. And then see, if you can download the data from website, yeah, it is, I think it is a comma separated value file. And then once it's downloaded, if you save that as a XLS file, you collected the data from the website. You got it? Yes, data collection you did. And it is a secondary method. It's not a primary. Secondary data collection, you did it. And then look for the data. If it is clean or you want to do something like taking into the Power Query or you want to shift, if it is clean, don't do anything. Perfect. Almost all the data here I noticed is a perfect data. Okay, I can show that. And then, so what is your question? What sort of visualization will best work for your question? Is it a pie chart or a bar chart or a scatter plot? So decide that. And then, yeah, if you come to this point, put a check mark. And then finally, analyze. And then, yeah, do whatever that is possible with this data. And then this Wednesday, we'll take a few minutes to discuss about this one, okay? All right, so this is what we have. Let me